Hello, I'm your TA. In this video, I'm going to share you an example of two-way MANOVA with no interaction. We are doing a main effect up to the follow-up test with Tukey. This was November 2nd in class activity in 682. We have two factors, variety and location, and we have three dependent variables. So we need to run two-way MANOVA with a significance level of 0.05. We need to conduct a two-way MANOVA because 2 means the number of factors. We have variety and location. And M as MANOVA stands for the number of dependent variable. We have 3 dependent variables. That is why we need to conduct two-way MANOVA. Before starting interaction effect, we need to draw the data structure. We need to calculate the mean of each cell. So I write the Greek letter mu, and first subscription refers to the location, and the second subscription refers to the variety. The third subscription refers to the dependent variable. If you would like to change the first subscription as a variety, the second subscription as the location, and third subscription as dependent variable, you make a note for the order of the subscription. That is totally fine. I drew this table and I wrote the mean of each cells. So my first subscription stands for the location. This cell is the first location and fifth variety. So 5 is in second. First dependent variables are in the last subscription. For example, so this cell corresponds to the second location. So I put the 2 in the first. And this cell corresponds to the third level of the variety, which is 8. So I put the 8 in the middle subscription. And I am working on the first dependent variable. That is why I put the 1 at the end. So you can fill out each cells by having the level of each factors with dependent variable. And then we need to calculate the mean vectors. Across all locations, if I want to calculate the mean of this column, across all, which means we don't care about the level of the location, I put the dot here. And then the first level of the variety, which is 5, I put the 5 in the middle, and we are dealing with the first dependent variable at this point. So I put the 1 at the end. The second column is regardless of the location level, so I put that in the first subscription because we don't care about the level of the location. And I put the 5 in the middle because we are working with the first variety level, which is 5. And we are working with the second dependent variable, so I put the 2 at the end. This cell mean is we are working on the first level of the variety. So I put the 5 in the middle across all the locations. That is why I put the dot in the first subscription. And I put the 3 in the last. I can write mean vector of a first level of the variety. Mean vector for the location 1 across all the variety, because we across all the variety, that is why I put the dot in the second subscription, because across all, which means that we don't care about the level of that factor. The mean vector of the first level of the location across all variety level is mu1 dot we need to start from the first dependent variable. So first dependent variable is highlighted as pink. So I need to combine all the data in these three cells, and then I need to calculate the average. So 151, 161, 181. The location number is 1, so I put the 1 across all the variety level. That is why I put the dot in the middle, and I am considering the first dependent variable. That is why I put the 1 at the end. I am highlighting as the purple. I need to calculate the mean of these purple cells. So location 1 and across all variety level. So I put the dot in the middle, and I am considering only the second dependent variable. I put the 2 at the end. The last one is about the third dependent variable. So I need to calculate the mean of these brown cells. So for the first level of the location across all variety levels, so I put the dot in the middle, and we are working on the third dependent variable, so I put the 3 at the end. So this is mean vector of the first level of the location. I need to make a note. So mu LVD means the mean of the data in Lth level of the location vector, which comes first. So that is why I put the L, and the Vth level of the variety vector. So that is why I put the V, and the dependent variable. So I put the D at the end. I need to explain what is the meaning of the mu LVD, and I need to explain the subscription. The first subscription refers to the level of the location. Second subscription refers to the level of the variety vector. And third subscription refers to the dependent variable. We need to start with the interaction effect. My null hypothesis is there's no interaction effect between two vectors in terms of dependent variables. And my alternative hypothesis is there is an interaction effect between two vectors in terms of all three dependent variables. I'm going to show you how to upload the data and SAS code in SAS Studio. In the SAS Studio, I need to log in because I want to upload my data under the data folder. I click the data folder and then I hit the upload button. I click this file, open, upload. And then I could see here, peanut XLSX, double click this one. Under the output data, I click the change and I change this one as peanuts. Save, and then I need to run with the person who is running in treadmill. In output data, I could find there are 12 rows and there are location, variety, and 3 dependent variables are here. And then I need to save with save button. So just in case, I click the data because I want to save this new file under the data folder and save. And I have peanuts CTL data here. I would like to upload my SAS code file. So click the code because I would like to save my code file under the code folder. Click the upload icon, choose files, and two-way MANOVA peanuts SAS. Open, load. If I double click it, I could see this code. This is a SAS code. So by using the GLM function in SAS, and I let SAS use the data with peanuts, I saved as peanuts.ctl. We have two factors, which is location and variety. And the model is something in the left side is dependent variable, and on the right side are the independent variable, which is factors. Factor 1, factor 2, and the interaction of two factors. Here, I have the interaction table at the end. If you scroll down under the bottom, you could find the no overall, location, timed, variety, which is the interaction effect. So we need to see this table, especially this row for Wix lambda. So I copied the table here. No overall one factor times the other factor effect, which is interaction effect. I observed Wix lambda 0.043 and p-value is 0.0508 and p-value is greater than my significance level of alpha, which is 0.05. So I failed to reject the null hypothesis. So I don't have compelling evidence to conclude that there is an interaction between two factors, which are location and variety, in terms of three dependent variables. Because we don't have interaction effect, we need to conduct main effect test. And here is the SAS code. So we need to conduct the main effect for both factors. So for the location factor, we need to compare two mean vectors. We need to compare this mean vector versus this mean vector. So my null hypothesis is mean vector for the one dot equals mean vector of the two dot. And my alternative hypothesis is not equal because we only compare two mean vectors. Relation mean vector of the population mean vector of two levels of location are same across all levels of the variety vector. And my alternative hypothesis can be the population mean vector of two levels of location are not same across all levels of the variety vectors. For the main effect for the location, in the SAS, this is main effect for the location, and this is main effect for variety. So we need to see this row and this row for main effect for the location and variety respectively. So I copied two tables. So main effect for location, I need to see the no overall location effect, especially this row. Since p-value is 0.0205 is less than alpha, which is given in the question, with observed Wix lambda is 0.1065. Because p-value is less than alpha, we reject the null hypothesis. So I have statistical evidence to conclude that mean vector for two locations are different. And main effect for variety. Main effect for variety is try to compare these three mean vectors. So my null hypothesis is the mean vector of the first level of the variety, second level of the variety, and third level of the variety. So population mean vector of 3 levels of variety are same across all level of location vector. So I could write this null hypothesis in words. Alternative hypothesis is at least one of population mean vector of 3 levels of variety is different from others. As same as the main effect for the location, we need to see the no overall variety effect. This is a result of the main effect for variety. My Wix lambda is 0.01 and my p-value corresponding to the Wix lambda is 0.0019. So since p-value is less than alpha with Wix lambda, I reject the null hypothesis. So I have a compelling evidence to conclude that at least one of the mean vector for 3 variety are different from others. For both vectors, location and variety, we rejected the null hypothesis. If we reject the null hypothesis, we need to conduct a follow-up test. So I am going to a follow-up test with Tukey. Because mean vectors for each location and variety vector are not equal, I will conduct follow-up test with Tukey to figure out which dependent variable affects the difference of mean vectors. Also, which specific level of each vector means are different. I'm going to show you how to do this one in SAS. This is a code. And because we need to conduct the main effect with Tukey test, so I will erase the star sign and it changes to the blue letter. Because for both vectors, we rejected the null hypothesis. That is why I put the both location and variety. What if for the location factor, if I fail to reject the null hypothesis, I need to erase this location because for the location factor, we fail to reject the null hypothesis, which means that population mean vector of 2 levels of location are same across all levels of the variety vectors. So we were done. Until here, it was interaction effect and main effect. We need to see this one. From here, Tukey's HSD test for X1. For the X1 location and X2 for location, X3 for location, and X1 for variety, X2 for variety, X3 for variety. This is a SAS code. For location, X1 for location, X2 for location, X3 for location. We have only one bar here, which means that location 1 and 2 are same. Location 1 and 2 are same for X2. Location 1 and 2 are same for the third dependent variable. To interpret the result of each graph, I could say the sample mean for location 1 is not different from location 2 in the first dependent variable, which is yield. So I can write as in the parentheses. I wrote in the same pattern. I made a note. The result of Tukey's test on the sample means across 2 location levels are not significantly different. So we could find location 1 and 2 are not different. For all three dependent variables, it seems contradict the multivariate result. However, it can be happen because univariate test does not consider correlation between variables. For variety factor, when we conducted the Tukey, x1 for Tukey, x1 for variety, x3 for variety, we could see that 5, 8 are same and 6 and 8 are same. Simple mean for variety 5th and 8th are same, and simple mean for variety 6 and 8 are same. However, simple mean for variety 5 and 6 are significantly different. Therefore, I have compelling evidence that the mean of x1 is different between variety level 5 and variety level 6. And for the second variable, sample mean for V5 is significantly different from the V6 and V8 for second dependent variable. Therefore, I have compelling evidence that the mean of x2 is different between variety 5 and the other variety 6 and variety 8. For the third dependent variable, 5 and 6 are same and 8 is different. So sample mean for the variety 8 is significantly different from variety 5 and 8 for x3, which is seed side. Thus, I have statistical evidence to conclude that the mean of x3, which is seed size, is different between 8th variety and the other two variety, which is variety 5 and variety 6. Thank you for watching this video. If you have any question, please let me know. Bye.